Hello, this is Mr. Precella, and I wanted to do some financial math problems using a TI calculator. The one I have is a TI-83 Plus. Most of y'all probably have an 84 or Inspire, but it works similar to this. And this is a really interesting problem. And you're going to notice I'm going to be able to do it all with just this calculator. It's a two-part problem. To set it up, a woman is working and saving for retirement for 45 years. Imagine she starts off as a young lady saving $300 at the end of each month. And she keeps doing that for 45 years. She doesn't increase the amount or anything, just slow and steady, $300 a month. After she retires, after 45 years, she wants to make monthly withdrawals for 25 years. At that point, the interest rate's gone down. She's put the money in a really safe account. That's why interest rate is a little lower. She doesn't want to lose any of it. And it wants to know how much can she withdraw each month without running out of money for 25 years. So I'm going to do this using the financial app on this calculator. To get to it, I click App and Finance. And we'll use TVM. That's the true value of money. And you've seen some videos at this point over that. And it's a very useful there. So here it is. N is the number of payments, deposits, the number of periods. I%, you enter the interest as a percent. Present value, payment, future value, payment per year, and calculation per year. That should be the same number. Since this is monthly, it would be 12. And we were told she made these payments at the end of each month. So let's get started with the first part of the problem. Let's find out how much did she save over that 45 years. Well, if she saved this $300 for 45 years, there's 12 months in a year, she made 540 deposits, or set aside that $300 in her 8% account. There. Let's see. Present value. When she started her account, it was at 0. Okay, that's a sensible assumption. Now she's paying $300 a month, so we'll write the payment negative 300. And what we want to know is how much does she have in that account at the end of the 45 years. That's the future value. So to solve this, I'll say green, since solve is in green. Alpha, solve, hit the enter. Wow. So after her working for 45 years, how much does she have there? $1,582,361, and I'd call that 97 cents. Is that what y'all call it? Now, when she retires after 45 years, she plans to make monthly withdrawals for 25 years. So I'm now going to start the second part of this. I'm going to have to go through and change N and the interest rate. And this future value here is now a present value. So let's get started. Okay. So she's going to be withdrawing for 25 years, making monthly withdrawals. So that means there's going to be 300 periods. The interest rate is now 4%. The present value is this number here, $1,582,361. $61.97. Now this payment, that's what we're calculating, but I got to clear out this future value here. Why? Well, after 25 years, you're assuming that you'll have $0 left in the account. Okay? So I'm now solving for the payment. The payment's going to turn out to be negative on the calculator, but we won't enter the negative on here. Okay? The negative just means it's a payment. So each month she'll be able to take out $8,352.29. So let's come right here. Again, don't punch in the negative. $8,352.29. Oh, let me move this so y'all can see where it says check answer. It's a very good problem. Very nice. Okay. And I guess we were fortunate that she didn't increase her payments or change the amount she contributed for 45 years. Now, that would be a little bit messier if she did. Okay. But she's going to have a nice retirement. Okay. Though I'm not sure how many people nowadays get a job and keep it for 45 years. I guess I'm at 34, 35 years right now, but still. Let's go on to the next problem. And, this is how to find monthly payments. It's how you do a car loan or a house loan. It says find the monthly payment. Hold on, let me clear off some of these numbers from the calculator. Okay, so find the monthly, it's a car payment, car loan. $12,600 car loan. It's for 6 years monthly. The interest rate is 4.5%. Well, to punch that in, there's going to be, 6 years, 12 payments a year. So altogether, we're going to have 72 payments. The interest rate is 4.5%. The present value of the loan is $12,600. That's what it's starting off at. And by the end of the 6 years, we're sure hoping it better be down to 0. So the future value is 0. To calculate that payment, alpha, enter. So what is that? Round to the nearest cent. So again, the calculator shows it as negative, but you don't enter the negative. You enter $200. And is that 1 cent? Okay, the digit after the 1 is a 2, so just drop all of that. Check our answer. Let's see the next one. Oh, same type of problem. Okay, I pause for a second to clear out that calculator so all those numbers aren't there. Find the monthly payment, same type of problem. 5-year loan, so 5 times 12. So that's going to be 60 payments. The interest rate is 3.6. The present value, okay, so they're buying a little bit fancier car, $44,550. Future value is going to be 0 because after the 5 years, you better have it paid off. Alpha, enter. Oh, so this car loan, again, don't enter the negative. The negative just means it's a payment. That's what the calculator's doing. But for us, what's it, $812.44. In everyday life, you don't say your car payment is negative, but the calculator sure treats it like that. Let's see. Okay, can we do this? Just ignore these numbers. Find the monthly house payment to amortize a 10.8% loan of $220,200 over 15 years. So it's a 15-year loan, and you're making monthly payments. The interest rate, 10.8. The present value, that's how much the car or the house is worth today. Wouldn't this be a funny car loan? $220,000 car. Now, the future value should be 0, 12, 12, and assume it's at the end. And sometimes students say, oh, well, I make my house payment, it's due on the first of the month. But it's still a ordinary annuity, and at the end, because you lived in the house for 1 month, and at the end of that 1 month, you make a payment. So unless it says beginning, you assume end. And let me see, did I alpha enter? Okay, so that house payment, rounding to the nearest cent, $2,475.20. Hope y'all see how nice it is to work these problems using a calculator like this. I don't want to bog you down with those formulas. This really isn't supposed to just be a formula class. If you want to see it done with the formulas, view an example doing that. But what I want you to be able to do is analyze the problem and answer the question using, well, this is hardly modern technology. The TI-83 has been around for what, almost 30 years. But let's do one more. Find the monthly house payment necessary to same type of problem. So here it's a 25-year house loan. Most loans for houses are either 15 or 30, but there's nothing that says it has to be. So here someone's getting a 25-year loan. They're going to make 25 monthly payments. So N is 300. The interest rate, 9.6. The present value, that's the amount of the house loan. And future value is going to be 0. So we just got to say, calculate the payment, alpha, enter, or alpha solve, whatever you want to call it. And we get $1,810.63. Hopefully you see how nice these problems work out like this.